Hi dear students, this is the third lesson about comparing and about ratios, and our subject is comparing ratios. There are three methods to compare ratios. One of them is to write them and reduce them to their simplest form, which is equivalent ratios also. So the first form is simplest form. And the second one we may convert them to unitary ratios. So the second method is unitary ratios, and the third one is convert them to percentages. So we may convert them. There are three ways to compare the ratios. We are going to start with equivalent ratios, so we are going to write them in simplest form. So the first exercise, compare the ratios 35 to the 84 and 64 to the 144. See if they are equivalent. So I'm going to try to find common numbers that divides 35 and 84. 35 divided 35 to 84. As I see, 35 has factors like 5 and 7, so 5 doesn't divide 84. I'm going to check 7, so 35 divided by 7, it's going to be equal to 5, and 84 divided by 7, it's going to be equal to 12. So this is equal to 5 to 12. And we are going to compare with 60 to 144, this one, 144 it's going to be. So 60 to 144, they are both divisible by 2. If we divide by 2, it's going to be, or 60 is divisible by 12 and 144 is divisible by 12. So if I divide by 12, this is going to be equal to 5, and this is going to be equal to 12. So this is also equal to 5 over 12. So we can say like this: these two ratios, they are equivalent to each other. So we can compare them and we can say them they are equal to each other. Okay, let's see these exercises here. Are they equivalent to each other or not? 15 to 25, the first exercise I'm trying to solve. 15 to 25, and let me find firstly 15 to 25. Then I'm going to check 12 to 18. They are both divisible by 5. I am dividing by 5, then it's going to be equal to 3 and 5. So these are prime numbers. We may not continue. And the second part is and, I said 12 to 18. 12 to 18, it's going to be when they're both divisible by 6, I think 12 divided by 6, it's going to be equal to 2. 18 divided by 6 is equal to 3. So as you see, they are not equal to each other. So they are not equivalent. Not equivalent. And the third one, let's solve on this page. Let's solve the B and check 36 to 16 and 45 to 20. 36 and 16, they are both divisible by 4. So if you divide by 4, this is going to be equal to 9. And 16 divided by 4, it's going to be equal to, here this is 9, this is 4. So this is 9 to 4, it's going to be. And 45 and 20, they are both divisible by 5. When you divide 45 by 5, it's going to be equal to 9. And when you divide 20 by 5, it's going to be equal to 5. So the answer, this is 4 also, 9 to 4, and this is also 9 to 4. So we can say like this: they are equivalent to each other. The other exercises, they are going to be homework for us. Okay, the second method is unitary ratios. If the ratios are different, the simplest forms are not always easy to compare. So I'm going to use unitary ratio for this comparison, and unitary ratio is the ratio form 1 to n or n to 1. So we are going to divide one of the side by the same number, then we are going to get 1 on that side, and we are going to evaluate this one. If I try to explain this one, it may be like this. Let's say there are 3 beads and 3 blue beads. blue bead and 5 red beads. The ratio blue to red, it's going to be 3 to 5. This is the ratio, but if you want to write this one in unitary ratio, I need to divide with one of them. I can divide like this. If I want to form this one, let's say this is the first form, so I'm going to divide both sides by 3, 3 divided by 3, so 5 divided by 3. The answer is going to be 1, 2, 5 over 3. This is approximately 1 to 1.6 it's going to be. So this is the way to get the unitary ratio. Also, this is the form 1 to n. If you want to find another unitary, second unitary, if I say unitary, 3 to 5 again, when I apply the unitary method, this time I'm going to get n to 1, which is equal to 3 over 5 divided by 2 5 to 5. When you simplify this 2, this is going to be equal to 3 over 5 and 3 over 5 to 1. So this is the second method, and n becomes here 0.6. 0.6 to 1 it's going to be. So this is the second way to convert this expression 3 to 5 into unitary. Which one is helpful for us? We may use that one, and we may compare two different ratio with respect to this one. Okay, let's solve this exercise and we will understand better. There are two schools now. There are 565 and 27 students. So it's looking for the lower student to teacher ratio, and the student to in the first school, student to teacher ratio is 565 to 27. In the second school, the ratio is, I'm going to use different color for this one, not to mix with the other side. So 565 to 27 is the first one, and the second one 840 to 37 it's going to be. And since it is important for me to learn the how many student to teacher, that's the why I'm going to student to teacher, I'm going to divide by teachers number, both ratios, which is equal to, for the first one 565 to 27, both of them they are divided by 27, and I'm going to use calculator to do this operation. That's going to be equal to 565 divided by 27 to 1. This is the student to teacher ratio for the first school, for the Midtown school. And 565, here it is calculator, 565 divided by 27, it's going to be equal to 20.92. It's going to be equal to 20.92. I'm going to write one decimal place, so it's going to be 20.921. It's going to be, so this is for 20 students, there is one teacher. It means that one. This is the first school for the Midtown. For the second school, I'm going to do the same thing here. 840 divided by 37, it's going to be this time. Both of sides we are going to divide by 37, and this was the ratio here I'm talking about, 840 to 37. And if you divide both sides by 37, this side it's going to be equal to 1. 840 divided by 37 to 1. So for one teacher there are 840 divided by 37 students, which is equal to, if we clean this part, 840 divided by 37, it's going to be equal to 22.7. So the answer is, to one decimal place, if I simplify, 22.7 to 1. This is the ratio of the Clayford School, Clayford School. So which school has the lower student to teacher ratio? Midtown has less ratio than the Clayford school. Okay, another method, and the third method, using the percentages. We are going to convert ratios to the percentages. Let's give example. Let's say there are 3 bits to 7 bits, and what is the total ratio of 3 red bits and 7 blue bits? So what is the ratio of them? Here we are going to use this method. Firstly, we are going to find the whole, because sometimes we need to use the whole if there is a mixture like this. What is the red bit to all? If we say that's going to be equal to 3 plus 7, there are totally 10 bits here. And the percent of the red bits is, what is the percent of red bit if you want to compare, because when you want to compare, it's going to be equal to 30%. How to find that one? 3 over 10 to 7 over 10 also it can be. This is because I'm dividing by same number, and this is 0.3 and I'm writing here 0.7. And when you multiply this one by 100, you will get the percent. When you multiply by 100, you will get the percent. 0.3 times 100, that's equal to 30%. And 0.7 times 100, that's equal to 70%. So that's 70% it's going to be. And now there are 10 bits. In 10 bits, 30% is red and 70% is blue bit it's going to be. So this is the way to compare two ratios also. Here there is only one number, but we are going to compare them here. Also, we may compare two different mixtures with different values. This is the exercise for that one. 240 milliliter red paint to Raymond mixes, red paint to 560 milliliter white paint, and let's find the mixtures ratio. 230, firstly, if we add to 560, we will get the total amount of the mixture, which is equal to total density, or total mass of the mixture, which is equal to 240 plus 560. That's equal to 800 milliliters. So the ratio to 240 to 800, this is the first ratio, and the second one is going to be 0.75 plus 1.25. That's equal to red paint and white paint sum. That's equal to 2 liters. These expressions, they are all in liters here. Okay, so the answer is 2 liters, and the ratio red to all is going to be 0.75 liter to all, which is equal to 2 liters. Or let's not write anymore, because this is the ratio now. 0.75 to all, it's equal to 2. So how to compare them? You can use simplifying method, or you can use the percentages. Means you are going to write first one of them in decimal form, like 240 divided by, I'm sorry to write different colors, 240 divided by 8 and 800 divided by 240 divided by 800 and 800. So this is going to be, when you simplify this two, it's going to be equal to 1, and here this two you simplify it, 24 over 80. Both of them, they are divisible by again 8, and this, when you divide, this is going to be 3, and this is 10. So 3 over 10, which is equal to 0.3, and as I 1. And as I said to you, from whole, that's 0.3, which means 0.3 times, if you multiply by here 0.3 times 100, that's equal to 30% over 100%. 30% over 100%, which means this is the percent of our first mixture, red paint in the mixture. Okay, second one we can do like this: 0.75 divided by 2, both of them divided by 2, so this is equal to 0.75 divided over 2, sorry, let me rewrite this part. 0.75 divided by 2, this is 2 over 2, that's equal to 1 also. 0.75 over 2, it's going to be equal to 0.37.375, which is equal to 30. If you multiply by 100, this one, if you multiply by 100 both sides, it's going to be equal to 1. This is 37.5% of whole percent, which is 100%. So for the first one the ratio is 37%, in the second one the ratio is 35. In the first one 30%, in the second one 37%. So who has the higher proportion of red paint? This is the higher ratio of the red paint is going to be.